Alrighty. Alrighty here. Alrighty, I am demonstrating a little circuit. Turn down this radio here. I'm demonstrating a little circuit that I designed. It's absolutely nothing complex or nothing, new or anything like that. It's just customized for the application needed. But the reason I had to design this specific circuit, this right here is basically just simply a transmit LED circuit. It's a transmit LED circuit with current limiting, and it's also got a built-in keying circuit as well. And a lot of you builders out there might be asking, well, why would you need a transmit circuit? All you have to do is take an LED, put power to the LED, and hook in the negative lead of the LED to the negative lead of the coil to the relay. So when the amplifier is keyed, that it will connect a ground to the LED. Correct. That is totally correct. That's how I do my LED circuits. But I don't know if any of you builders know, if you've ever wanted to, let's say, power 24 LEDs, power 20 LEDs on a transmit, you'll notice that will not work. That will not work because it's pulling. It requires more current than basically from the ground. The ground connection that LED can handle, plus with the electrolytic that's on the keying circuit. It will not work. Will not work, and you always have to add an external relay of some sort of circuit like this. But the main reason for this is that the amplifier that was compiled there, the 2 driving 8 base amplifier. And it's got a relay for each section, a relay for the 2-pil section, a relay for the 8-pil section. So I asked myself, do I want to just run a ground wire from the 2-pil section? Then if the guy has the 2-pil section off, then the transmit LED ain't going to work. How about vice versa, 8-pil? He turns 2-pil off, 8-pil off, excuse me, just runs a 2. Don't work. How about if I run 2 from both? I'll be honest with you, I've never done that before, and with this project right here, is way longer than should be worked on. So I don't really have time to be doing testing. So I just went ahead and did this, which, as you're about to see, worked out just fine. I am new to all this. I've honestly just started designing my own circuits like this. The board don't look professional like it could, if it was a perf board, or if it was done professionally. But like I said, I'm a beginner in this thing. I haven't started making my own boards yet, which I am going to begin doing. But at this moment, as long as it works, right? So I'm going to show you what we got here. Here's our power source, 2 12-volt batteries in parallel. Here's where I'm getting the RF from. It's just the old preamp box I took the preamp out of, and just got an alligator clip onto the positive, the center lead of the coax. It's just coming from a radio on through. Hooked in the back of my normal linear I use. So that's where I'm getting the RF from. It's feeding into here. The red wire is the positive voltage wire, which is hooked up to the positive voltage. Black wire, negative wire, hooked into this cord right here, which is hooked to the positive voltage. And the white wire is the negative wire for the LED. We are sending positive voltage to this LED, not ground as you normally would. We're using a relay, when actuated, sends a positive voltage to this LED right here. So here's what we got going on. Alright. I meant to buy a 12 volt relay, fellas, but by accident I bought a 5 volt relay. And that's when Ohm's Law came into play, which I needed to practice anyway. So I did a little bit of calculations, and I think around 16 volts if I need exactly 5 volts to go to this relay, which if I remember correctly, on the coil is a 20 milliamp load if I remember correctly. It equals up to about right there at 350 ohms. So that's what this pot is right here is for. That pot right there is adjusted to 350 ohms. Which is allowing, at this point in time, I only got 12 volts going to it, so I hadn't tested it yet, but it's probably allowing something like 3 volts to go to it or something like that, 2 volts. On the other side here, we have a relay, a reed relay, and we have our keying circuit. See if I can get that in the picture pretty good there. And we got our keying circuit. Just a simple keying circuit using a quadruple 2 keying transistor. And the yellow, where this will be soldered in the circuit, will be hooking up to here, right here. So I'm going to go ahead and demonstrate that this works just fine. Let's go ahead and take the light away from it. Alright, got my microphone here. I'm just going to be keying up, which might be kind of tricky. Here, let's see. There we go. Here's the microphone. Key. Key. There's your transmit LED. Audio. Audio. There you go. First time I ever designed a circuit like that, but I'm learning. I know it's not. I know there's some of you operators out there, you're probably sitting there thinking, that's a simple circuit. Why is he making a video of it? Well, I'm sure you can remember when you first started off in the things, it's a little decent accomplishment to me. Oh boy, let me see if I can get this get you a better view of this board now that we are done demonstrating. Like I said, it ain't the prettiest thing in the world. Just use it to pretty much put it together here to hold. But there you go. 22 microfarad electrolytic, a 10 picofarad silver dip mica, a 2 MPPP keying transistor, and the diode is I think a 4148. No, that's the big one. It's geez, it's a glass diode. I forget. I believe it's a 4148. I think it's a 4148. Yeah, I believe it is. So there's your keying circuit right there. 10 picofarad. That's where the RF is coming in at. Quick overview if anybody's ever wanted to know how a keying circuit works. This capacitor right here, this 10 picofarad capacitor, takes a small sample of the RF coming in, which that was the green wire that's hooked up to the center. See the coax coming in, coax going out. That red right there that's hooked, the green alligator clip's hooked up to, that's just the center lead. So the small 10 picofarad capacitor takes a small sample of the RF. Then it goes through the glass diode and is rectified from AC voltage to DC voltage. Then the electrolytic smooths it out. So you have a clean DC voltage that goes up through the center of the keying transistor. And with it going through the center of the keying transistor, it is just enough voltage to open this transistor. And then it will connect ground from the left lead of the transistor to the right lead of the transistor, which is then hooked up to the ground side of the coil of the relay. So the relay already has positive voltage going to it. It just doesn't have a negative voltage connected to it at the time. But then the second that you key up, that AC voltage coming from your RF, which is AC, alternating current, is rectified to DC voltage, cleaned up by the capacitor. And also the capacitor as well keeps the relay actuated also. It plays its two purposes. It smooths out the voltage, plus helps keep the relay keyed as well. And like I said, you're just creating a clean voltage to go through this transistor, because this transistor is pretty much being used as a switch. Once it goes up through the center lead, it opens the transistor and connects the left leg to the right leg, which means the left leg is hooked to ground, so it simply connects the ground to the relay. The relay actuates and sends the positive voltage being fed into the relay to that right there, which is the bottom part of the relay, which gives our positive voltage to our LED. And there you go. A little simple keying circuit enabled transmit LED circuit. And if this was a 12 volt relay, I would not have to have that right there. I would not have to have any current limiting. So there you go. And that right there can also be used if you ever want to do something neat and add 20 LEDs or whatever you want. Just make sure to add up your draw from the LEDs. Make sure the relay can handle it, which it should. But that can be used to pretty much do anything you want when the amplifier is keyed without it pulling excess, pulling away from the normal keying circuit or ABB biasing or anything else you got hooked up to the default relay. This is the Gatekeeper, and we're signing out. 73rds.